Hi, welcome to my video on review 1 of congruent triangles. And this review will not be treated as a quiz because it's hard to mark or assign marks to proofs. So just treat it as just a review. Review of congruent triangles. We have a diagram and we're given that angle 1 equals angle 3, and we have to prove that angle ABD, which is this angle here, is equal to angle CBE, which is this angle right here. So this is the bigger angle, these are the smaller ones, so we're going to have to add. So angle ABD is made up of angle 1 and 2. So we're going to have to add the angles together. So angle 1 equals angle 2, given. Sorry, angle 1 equals angle 3, given. Number 2, angle 2 equals angle 2. It's reflexive, an angle, reflexive property. An angle is equal to itself, and now we can go angle 1 plus angle 2 equals angle 2 plus angle 3, and that's the addition property of equality. We're taking 1 equals 3 and 2 equals 2, so we're adding 2 to both of these angles. Number 4, angle ABD is equal to angle 1 plus angle 2, and angle CBE is equal to angle 2 plus angle 3, and that's, we call it the angle addition property. Angle ABD is equal to angle 1 plus angle 2 added together, and as a result, because 1 plus 2 equals 2 plus 3, and here they are, 1 plus 2 and 2 plus 3, that means that angle ABD is equal to angle CBE, transitive property of equality. And just a reminder, as in any of my videos, you can pause the video and work out the solution and then press play to see if you're right. Number 2, we have a diagram here. It says the PQ is perpendicular to RS. So PQ is perpendicular to RS, so that means that this is a right angle here and this is a right angle. And it says that PQ bisects angle NQK. So because it's a bisector, that means 2 is going to equal to 3. And we have to prove that angle 1 equals angle 2. Okay, here we go. So these, we have PQT and PQR are right angles, so they're equal. And so these two angles, 2 and 3, are equal because of bisector. So if I subtract them, PQT subtract angle 3, I'll get angle 4, and PQR subtract angle 2, I'll get angle 1. So we'll do the subtraction. So here we go. So we got PQ is perpendicular to RT, given. So that makes angle PQT equal to angle PQR. And the reason is that adjacent angles formed by perpendicular lines are equal. And we got angle PQT equals angle 1 plus angle 2. Angle PQT is 1 plus 2. And we have angle PQR is equal to angle PQT is 3 plus 4, better be careful. PQR is 1 plus 2. And that's the angle addition property. And now we have angle 3 plus angle 4 is equal to angle 2, angle 1 plus angle 2, because they're equal here, and that's the transitive property of equality. Again, just to remind you, PQT equals PQR, there they are right here, so that means 3 plus 4 equals 1 plus 2, and well, PQ bisects angle NQK, that's a given. And as a result, we have angle 2 equals angle 3, definition of an angle bisector. And 3 plus angle 3 plus angle 4 is equal to angle 1 plus angle 2. 2 is equal to 3. That means that angle 4 is equal to angle 1 by subtraction. S-U-B. Subtraction. Make that an S, official S. Subtraction. Property of equality. So angle 1 equals angle 4 equals angle 1 is the same. Okay, let's continue with the review. Remember, pause the video and work out your answers to see if you're going to get them right. We have a diagram. We say T is a transversal, and fill in the blanks. Alternate interior angle to 2. Alternate interior angle to 2 would be angle 3. Vertically opposite angle to 5. There's angle 5. Vertically opposite would be a 3. Corresponding angle to 2. Corresponding angles are on the same side of the transversal. One is interior, one is exterior. 2 is interior, so corresponding would be 5. Alternate exterior angle to 1. Alternate exterior, alternate means across the transversal and the exteriors, so it would be 5. 1 and 5 are alternate across the transversal and exterior. 5. Hopefully everything is going well. Let's continue. We have another diagram again, and it says T is a transversal cutting through, and notice we have also that A is parallel to B, so we can mark that with the arrows. A and B are parallel, T is a transversal. State the reason why 1 is equal to 3. So 1 is equal to 3 is called PLT, and their 1 and 3 are corresponding angles. Corresponding angles equal. And the real statement is, if a pair of parallel lines are cut by a transversal, the corresponding angles are equal. But the shortcut is called PLT, corresponding angles equal. 4 equals 8. 4 and 8 are equal because they're alternate interior angles. They're interior angles across the transversal. So it's again PLT, and they're alternate interior angles equal. 3 is equal to 6. 3 and 6 are equal. They're exterior angles and they're across the transversal, so they're alternate exterior. So it's a PLT, alternate ALT, exterior angles equal. And why is 2 equal to 8? 2 is equal to 8 because there's two lines intersecting. The vertically opposite angles are equal. So 2 equals 8, vertically opposite angles. VOAT or VAT, depending. Vertically opposite angles are equal when two lines intersect. And number 5. We have, in this diagram, we're given that AE is parallel to WC. AE is parallel to WC. And with parallel lines, we have equal angles. So because these lines are parallel to each other, then this angle A is equal to angle C, alternate interior. And also because the lines are parallel, we got another transversal here. That means this angle here at E is equal to the angle at W, alternate interior. So we need to prove that angle W equals angle 1. So if angle W is equal to angle 1, there must be an angle hopefully equal to the two of them. We don't have congruent triangles because there's no equal sides. So let's angle W and 1. So what angle is equal to 1? Well, I'm going to mark a 2 here. Angle 1 and 2 are equal by vertically opposite angles. And angle 2 and W are equal because of alternate interior. So we have it that 1 is equal to 2, VOAT, 2 is equal to W because of alternate interior, therefore W is equal to 1. So here we go. The parallel lines gives us a pair of angles equal. So the angles that I want to pick are angle W is equal to angle 2. Angle 2 is equal to angle W because of PLT, alternate interior angles equal. Number 3, we have angle 2 equal to angle 1. VOAT, vertically opposite angle theorem, or VAT. Again, repeat, if two lines intersect, the vertically opposite angles are equal. And that means we have W equals 2, 2 equals 1, so angle W equals angle 1 by transitive property of equality. Okay, hopefully everything is going well. You're getting your questions right. If not, look how I'm doing them and correct yourself. Number 6, we have a diagram here and it says that PF equals PT. So let's mark those. And it has to prove that 1 equals 2. So if 1 is going to equal 2, I need to get somehow them connected. So I see that these two segments are equal in this triangle. This is an isosceles triangle. And so if two sides are equal in the triangle, two angles are equal. So this angle here, we'll call it 3, and this angle, call it 4. Rather than go PFT, I'll say 3. Rather than go PTF, I'll say 4. And check with your teacher if you're allowed to put those in. So here we go. We have two sides equal, so 3 is equal to 4. 1 is equal to 3 VOAT. 2 is equal to 4 VOAT. Therefore, 1 is equal to 2. So here we go. PF equals PT. Given. Angle 3 equals angle 4 by ITT, isosceles triangle theorem. And the whole statement for that, if two sides of a triangle are equal, then the angles opposite to those sides are equal. Let's call it the short way is ITT. Number 3, angle 1 equals angle 3. Angle 4 equals angle 2. VOAT, vertically opposite angle theorem, or VAT. And because 3 equals 4, and 3 and 4 are here, that means 1 is going to equal to 2. So angle 1 equals angle 2, and it's the transitive property of equality. But I'm going to mark 2 there, there's 2 transitives. In other words, what I'm saying is that if 3 equals 4 and 1 equals 3, that means 1 equals 4. And because 1 equals 4 and 4 equals 2, that means 1 equals 2. So there's 2 transitives. But rather than write the 2 of them, I just write that down and put a 2 behind it. Number 7, state the converse of. If a triangle is equilateral, then all of its sides are equal. The converse is switched around. If a triangle has all sides equal, then the triangle is equilateral. So a converse is just switch the if and the then around. And another proof, number 8. We have this diagram, we have IH is equal to IX, mark them. We have WK equal to XW, WK, XW, okay. Notice I marked these with 1 stroke, these with 2 strokes because they're different segments. We have to prove that IH, this segment, is parallel to KW. And to prove that, well, if we had the parallel lines, we would have angles equal. So pretend if these lines are parallel, then we would have K equal to H, or we would have W equal to I, alternate interior. So to prove parallel lines, we need to get a pair of angles equal. So we need to get either I equals W or K equals H. So what are the givens going to do for us? Well, because these two are equal, that means this angle, I'm going to call it 1 equals H. Because these two sides are equal, that means K, mark it with 2 strokes, is going to equal 2. And the connection is 1 equals 2 by VOAT. So since 1 equals H and 2 equals K by ITT, 1 equals 2 by VOAT, to connect them all up, we have H equals K, and these are the angles equal to get the parallel lines. So we have our proof. I'm going to separate the givens so you can see the different ITTs on the go. So because IH equals IX, that means angle H is equal to angle 1. And that's 2 ITT, isosceles triangle theorem. And now we'll go WK equals XW. This is the other given. I didn't put all the givens into one step because I wanted to show you the 2 separate ITTs. Because these 2 sides are equal, that means that angle 2 equals angle K, and that's ITT. Number 5, now we have to get those connected. So we have angle 1 equals angle 2, VOAT, vertically opposite angle theorem. Again, if 2 lines or segments intersect, then the vertically opposite angles that are formed are equal. So that's why 1 equals 2. Now we got H equals 1, 2 equals K, 1 equals 2. So we have that angle H is equal to angle K, and it's the transitive property. But again, we have to do it twice. In other words, what we're saying, h equals 1 and 2 equals k, but we got 1 equals 2. So 1 equals 2, we have h equals k. 1 equals 2, h equals k, transitive property. Twice. And number 7, we got the angles equal. Number 6, because these angles are equal, that means IH is parallel to KW. And that's angles equal, so that's the converse of the PLT. To get parallel lines, we need a pair of angles equal. So they're converse of PLT, so these two angles, H and K, are alternate interior angles equal. Again, this is the transversal, cutting these two lines. So since these two angles are equal, alternate interior lines are parallel. Okay, continue. Fill in the blanks. Remember, my review is designed in the order of my videos that I've done on the unit. Fill in the blank. Triangle ABC is congruent to triangle DEF. So BC is equal to, B goes with E, and C goes with F. An angle ACB is DFE. Again, A goes with D, B goes with E, C goes with F. Number 10, state the reason why each pair of triangles are congruent. So we have a side marked, we have an angle marked, we have a side, so this is an SAS congruency. And why are these triangles congruent? We have these two sides marked equal. We have a reflexive here, this common side, and we have this angle. So we could name it, we could have a pair of right, because these are perpendicular here, is perpendicular right here, so this is a pair of right triangles, so we could go hypotenuse leg congruency. And you could also state also another reason is that if these two sides are equal, that means this angle is equal to this one. So that means that we have, if we make these two angles equal, because they're perpendicular, they're right angles, then these two triangles could be congruent by AAS. Or we could go this way, AAS. So we could also have an AAS congruency here. Number 11, state the congruency relation for each pair of congruent triangles. The congruency relation, so that's marked with one stroke, so A goes with H. So let's pick a triangle. Let's pick triangle AOE. It's congruent to, let's see, because OA goes with OH, A goes with H. And because I have OE equal to OT, and O is common, so E has to go with T. And we got vertically opposite angles, so this angle here is equal to this one, so O goes with itself. So AOE goes with HOT. B, we have these two sides marked equal. We have these two angles marked equal. And we have PR is common, so we'll mark that. So let's pick a triangle. Let's pick PRQ. And what triangle is it congruent to? Well, P goes with P because they're equal. And PQ is equal to PT, so P goes with P, Q got to go with T. And that means R has to go with R. PR is common, so we have PR is reflexive or common. So P goes with P, R goes with R, Q goes with T. There's the two triangles. And another proof. Let's see how this proof is going to go. O is the midpoint of MT. And again, just remind you, don't forget to pause the video and work them out before I do. O is the midpoint of MT. If O is the midpoint, OM equals OT. MT bisects AH. So if MT bisects, it means that OH is equal to OA by bisector. Definition of a segment bisector. And I also see that this angle equals this one by vertically opposite angles. So that we could have the triangles MOA. Notice MOA. M must go with T, O goes with O, so A goes with H. So the triangles are going to be congruent by SAS, side, angle, side. So we got number one, O is the midpoint of MT, given. That means OM equals OT. Definition of a midpoint. Number three, MT bisects AH, given. And that means that OH equals OA. Definition of a segment bisector. And we have angle 1 equals angle 2 by VOAT or VAT, vertically opposite angles. Again, if two lines intersect or two segments intersect, then the angles formed are equal. Opposite angles formed are equal. And we have these two sides equal, these two equal. So in this triangle, I got an ASA. So triangle MOA is congruent to triangle TOH, and it's an SAS congruency. Okay, we have one more proof to do. And let's see what we have here. Okay, let's go through. I like to do the proof in my head first, and then organize it after. NA equals EC. Marked the wrong one. Sorry about that. AC, which is this long one, equals BD, which is this. Okay. And I can see that BC is common here. So if I subtract BC from both AC and BD, then I'll get AB equals CD. So I'll end up with this segment, AB equal to CD. And we have the parallel lines, so we have NA parallel to EC. Because the lines are parallel, then we'll have angles equal. Parallel lines will give us equal angles. So what angles are equal? This angle A is going to equal this angle C here. And you can see that if I get this segment, if I get AB equal to CD, then the triangles will be congruent by side, angle, side. And if I want to prove that NB is parallel to ED, if these are parallel, then these angles are going to be equal. So what I have to do is get my triangles congruent, and say that these two angles are equal, and then I'll have the parallel lines. So let's put in some, I got angle A is okay, let's put a 1 right here. Instead of saying ECD, saying a 1, let's put a 2 here, and this, we don't need the 3 here because that's D is the angle, so I'm putting 2 here so I don't have to say NBA. And now I got it all put together. So NA equals EC given, and put in, this is the column statement, this is the reasons column. Number 2, I got AC equals BD, and AC is equal to AB plus BC, and BD is equal to BC plus CD, and that's the segment addition postulate. If I can spell postulate correctly. Number 4, we have AC equals BD, and there they are, so that means that AB plus BC is equal to BC plus CD, and that's the transitive property of equality. Again, AC equals BD, there they are right here. AC, BD, so these two added together must equal those two. Now we have BC is equal to BC, reflexive property. And he said BC is equal to itself. And as a result, we'll have AB equal to CD by subtraction. Property of equality. And now we have, let's see, we need the parallel lines now. NA is parallel to EC, given. NA, that means that angle A is equal to angle 1, and that's the PLT. And there, notice it's not alternate interior, this time it's corresponding. Corresponding angles equal, because they're on the same side of the transversal, they're not cross. That means we have AB equals CD, we have NA equals E or EC, and we have these angles equal, so the triangles, let's see, N, A, B, N goes with E, A goes with C, and B goes with D, and that's a side angle side. And as a result, we have angle 2 equal to angle D, CPCTC. Number 11, we have NB parallel to ED, because these two angles are equal and they're corresponding angles, and there's the transversal cutting through these two lines. These two lines are cut by this transversal, so these two angles are equal. So that's the converse of the PLT. Corresponding angles And that brings us to the end of the first review. I have another review because I didn't want to make it too long. And if you like my review, then you click on the like button, subscribe button. If you're new to my website, I should say, to my YouTube channel, click the like button, subscribe button, notification bell. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel. Check it out, and you see all the content there. Thank you for viewing my video. Bye-bye.